So the big news in the amateur astronomy world today and the professional astronomy world is Sunspot 2192. It's a mammoth, it's a behemoth. It's what I'd call the Godzilla of sunspots. This thing is huge. It's several times the size of the Earth. And if you've got a simple solar filter like this is an eclipse viewer, you've got yourself a pair of eclipse shades, put them on, have a look at the sun. Just no magnification, you can't use optical instruments with these sort of things, telescopes or anything. Just put them straight up to your eyes, have a look, see if you can see that sunspot. If your eyes are any good, you know, you might need to put your glasses on, have a look to see if you can see it. Here's a view of my daughter, Georgia, having a look at this sunspot with a pair of eclipse viewers. So Georgia, describe to me what you can see.
I can see the sun and there's a black dot up the top. How do I see it? Because the sun's pretty far away, how would I be able to see the black dot from here?
Well, the black dot's so big, George. It's many times the size of the Earth. That's why you can see it.
Awesome.
It's just literally so big. It's bigger than planets. And I mean, the sun's pretty huge itself, but that sunspot, compared to other sunspots, it's massive, and that's why you can see it with the filtered naked eye.
Awesome.
So as we were filming this segment today, this sunspot 2192 produced a massive X1 class solar flare. Now that's the top of the scale as far as X-ray flares goes. We don't know yet whether it's produced a coronal mass ejection. Doesn't really matter whether it has or it hasn't. It's not pointed towards the Earth at the moment. But as the week progresses, it's going to rotate around more so that it's facing us, so that if this region becomes much more active again and produces a coronal mass ejection, it'll spew out all this solar material towards the Earth. It'll race towards us, interact with the Earth's magnetosphere, and hopefully cause aurora. And that's what aurora chasers like myself are after. And if it's big enough, we'll see something like this from Wollongong. Most people think, you know, we're just south of Sydney, we're at latitude 34.4 degrees south. Most people think that you can't see aurora from this far north of the South Pole. Well, you can. It is possible. You need to know when to look, and hopefully there's no moon around as well. You get plenty of dark, clear skies. You can see aurora when these coronal mass ejections occur. Usually takes 2 or 3 days after the ejection for the aurora to happen. So fingers crossed, as this sunspot rotates around, it'll do something really interesting for us. What lots of people are going to try and do, we're going to try and get that key shot as the sun sets. I'm going to go set up for that now with my telescope gear and my Canon camera. We're just going to try and film it, and let's see if we can get some good footage from this.
I drew the sun, and the pink dot here is the spot that you'll see on the sun today, that my dad showed me through the filters.